Hello everyone and welcome back to Educator.com. I'm Dan Fullerton and in this lesson we're going to talk about power. Our objectives include calculating average and instantaneous power, calculating the power required to maintain the motion of an object, and calculating the work performed by a force supplying constant power. So let's start by defining power. Power is the rate at which work is done, or it's the rate at which a force does work. Units of power are joules per second, which we also know as watts, oftentimes given the symbol capital W. Gotta be careful, capital W in watts can look like capital W for work, so you gotta know what you're talking about, whether it's a unit or whether you're talking about the quantity work. Power, if we want to define average power, is the change in work, or the amount of work done, in some amount of time. Units, as we said, are joules per second, or watts. Instantaneous power we can find by looking at the average power over a very, very, very small interval until we make that time interval infinitesimally small. So power is the time rate of change of work with respect to time. But we've also stated that that differential of work is F dot dr. So we could then write that power equals F dot dr with respect to time. But we also know that dr dt is our definition of velocity. So we can write, finally, power is also equal to force dotted with velocity. So a couple different ways to find our power. Let's do a couple examples.